Hello, welcome to FX PhD. My name is Matt Leonard and this is class number 3 of Katana 101. So in this class we're going to be looking at how to get information out of Maya, primarily as the 3D tool we're going to be using, and then into Katana and the pros and cons that we have, the constraints we have, and just the best way to go about it, because getting this part right is then going to make life in Katana much better once we begin to work in our look development and lighting pipeline. So the first thing that you tend to want to do when you're beginning to run some tests is to work out what the Alembic file format is actually able to export from your 3D application. And that was the first thing I did when I first started trying to get Maya and Katana to talk to each other. So I made a simple scene like this, which contains some geometry, a camera, a locator, a curve, and some lights. And the geometry, I really just used 3 different types: a NURBS sphere, a subdivision cube, and a polyplane that I added some UV information to. The lights were just all the lights that I generally used: point light, spotlight, area light, directional light, etc. And I grouped them all into some hierarchies, as you can see here on the left hand side. I also just made some empty groups that you can see as group parent, group child, and group child there at the top. And things like lights and the geometry I also put into separate groups, because I just wanted to see the hierarchical structure as I exported this from Maya as an Alembic file, and then wanted to bring that into Katana. So having done this, I then imported the file from Maya that I had made back into Maya to see what would happen. And you can see from this diagram, it was quite surprising what was actually being supported in the Alembic file. Now, I was running these tests in Maya 2013.5, which is the kind of subscription advantage pack, or the extension that has recently come out. And the Alembic version inside of that, I believe, is version 1.0.5. So it's not the latest version that was released at SIGGRAPH 2012. That version, Alembic 1.1, as far as I can work out, isn't supported in any of the mainstream programs at the moment, unless you happen to work for a facility that has taken the code and compiled it for either the 3D application you're using or your in-house proprietary software. So out of the box, we're limited to Alembic 1.0.5 at the moment. And you can see there's some noticeable differences. The green lines represent what has actually been exported and come back in and is in its original format. And it's actually reasonably limited. So the camera has been exported and come back in and looks fine, along with the curve and the locator. The polyplane and the NURBS sphere, still animated, all come back in. But the Alembic file has lost things like the subdivision cube. That came back just as kind of an empty group, along with all the lights. All the lights didn't come in at all, having been exported and then re-imported. And we know that that would be the case because only Alembic 1.1 supports lights. So it would be logical to assume that trying to export lights in Alembic 1.0 is really either going to mean that the Alembic file format just loses the light information, or it's converted to something else. And what we can see is it's just been converted to what appears to be just a group or an empty space. So this is what happens if you bring it out of Maya as an Alembic file and then just bring it straight back in. So what happens if we now take this data into Katana? What does it look like in Katana? So you can see here, this is the structure that we're seeing in the scene graph in Katana, and it's very similar to what we're seeing inside of Maya, which is really useful. So you can see that our master group still exists, but it exists in a higher structure than what we originally made inside of Maya. So Katana has added a root. Inside of the root, it's made another area called world. Inside of world, we have geo. Inside of geo, we have the scene graph generator, and then inside of the scene graph generator we then have everything we exported from Maya. And you can see from these green arrows where the things that we created have come across, how they're positioned, and the fact that they are all working. So that is a good sign. We now know what we can work with and what we can't work with. So there's no point in using lights or subdivision surfaces and also materials at the moment aren't supported. But everything else, locators, cameras, polygon geometry, NURBS geometry, and animation can all be taken out of Maya into Katana. So we now know kind of what we're working with. So let's have a think about the scene graph inside of Katana, and let's try and understand a little bit more about what it is. So the scene graph in Katana consists of a hierarchy of scene graph locations, and that's what we saw earlier. We saw that kind of hierarchical structure. Each location is a specific location type depending on the data it represents. Render plugins such as Arnold or RenderMan have specific behaviors when these types, and that's the location types, are encountered during looking through the scene graph. The viewer uses this information, so the type information, to determine how to display cameras, lights, geometry, etc. So depending on what the type is, and we'll have a look at how that's shown in the scene graph in a moment, depending on what that type is, that tells Katana whether that piece of information, when it's viewed, is a camera, a light, or some geometry. So that's quite interesting because you're actually able, inside of Katana, to take a polygon mesh or NURBS model, change the type, and actually have it displayed as something different. So that's something that you can do if you're getting into more high-end work. Also, the scene graph locations have additional attributes attached to them, and these attributes are organized in the hierarchy of groups and store the information in various data structures. So again, that's something that we'll be looking at later on in this course or the next. Now, if the renderer looks in the scene graph and comes across something that it doesn't recognize, that is basically treated as a group, and that's similar to what we were seeing in the Alembic file. When we were taking something out of Maya as an Alembic file, such as a light, and saving it as an Alembic file, and then looking at that Alembic file, you were noticing that the things that it wasn't able to work out basically were converted and treated as a group. And finally, the scene graph locations in Katana are duck typed. So if it walks like a polymesh and quacks like a polymesh, it is a polymesh. So pretty standard. A lot of applications work the same way. What it looks like is what it gets defined as. So this is what the scene graph looks like inside of Katana, and we looked at this last week, but let's look at it in a little bit more detail so we actually understand what's going on. So you can see that we have a number of types down the right hand side of the screen grab of the scene graph here. So the root is a group. We then have things like world, geo, and house scene. They're all groups as well. The tree is a component. The geometry are groups, the leaves are groups, but the leaf shape is actually a polymesh. Then we have the trunk of the tree, which is a group, and then inside that is the trunk shape, and again that's a polymesh. Then we have a house, and the house is an assembly, and we'll talk about the difference between groups, assemblies, and then a bit further below you can see there's a component. If you keep going down, you'll notice that there are lights, materials, and cameras as well. So really we have a whole mix of different types of things inside our scene graph, and this is really important to help get Katana to understand what things are, and also enable you to easily navigate through the scene graph, which can get incredibly complicated as your scene gets bigger. So let's just define what some of these are, and you can see on the right hand side I've already made a list of what is what. So a group is basically just a group. A component is a building block component, so they are kind of the building block structures that make up a number of components. Then you have an assembly, and that's the assemblies of other assets within the scene, and then everything else is pretty standard. Polymesh is just a polygon model. A NURBS patch is a NURBS model. A light could be any type of light, from a point, spot, area, depending on obviously what the renderer is and what light you've defined. But all lights are just defined as light. Cameras are just defined as a camera. And then material defines the materials, shaders, etc. Again, that would be defined by RenderMan, Arnold, or whatever you're using. Now there are a whole number of other standard attributes that you can use. So you can see that we have key locations such as root and root world. We have groups, assembly, component, and then group itself. We have a number of types of geometry. So we have polymesh, point cloud, submesh, NURBS patch, sphere, camera and lights. We have the materials that we talked about earlier, and then we have other. And other contains a whole mishmash of things that can be really useful. So you've got brick maps, collections, errors, face sets, infos, levels of detail groups and level of detail, which obviously if you've come from Maya and you're using level of detail in Maya, it enables you to define at what point a certain object is going to be displayed based on the distance the camera is from it or some other rules that you may have applied. You've also got light material, procedural, render procedurals, render procedural arguments, rib archives from RenderMan, and scene graph generator. So any of these could be shown as a type within the scene graph as you start bringing in more information or start generating things inside of Katana. Now, naming conventions are really important, and this probably has been mentioned before, but making sure that your models are named accurately is incredibly useful. And in fact, if you don't do it, you're really just losing the power of Katana. So it's worth taking the time to do it properly. So this is an old model I pulled up that I've had on file for ages. It's just a couple of buildings with some kind of structure between the two. But when you look at the outline on the left hand side, you can really see that when I made this, it was just kind of thrown together the way that you may be happy to work if you're in a rush or really just don't really have any naming conventions that you're using. So luckily my models have been put into groups, but they're really only called group 2 and 3, and within that we have just a whole mass of polycube 1, polyplane 1, polycube 2, polysurface, etc, etc. And so it makes it incredibly difficult if you wanted to actually go into Katana and start adding textures or lights to different attributes or different pieces of the scene. So what would be much nicer obviously would be to say this is the roof of one building, or this is the gantry of another, or this is a bolt, or this is whatever it is that you're trying to define. So here is a much better version, and this is the robot we used last week. And as you would have noticed last week, I spent a bit of time inside of Maya organizing this in a better way. So we have the body, and then the body contains various other groups. So we have the body left and right hoop, which are the hoops on top of his shoulders. We then have the shoulders themselves. Then the arms are attached to the shoulders. We then have the neck, which has the head attached to it, and then the head sphere, which is kind of the light on its head, and the left and right eye are attached to the head. Then we have the legs, the lower legs, and the feet. And that is a much better way of naming everything. It obviously takes a little bit more time, but makes such a difference when you then bring this into Katana. So let's just move across to Maya just to see how this works. So here we are inside of Maya. I'm just going to come in and I'm going to grab the good naming object. Now this is obviously very basic, but I just want to make it absolutely clear what we're doing. Okay, so here is our robot. I'm just going to turn off these guides. Now obviously when you begin to build this, you're going to be using various techniques, and you're going to end up with your message just named arbitrarily. But all you want to do is you just want to first of all work out the best structure. So I knew that the center of the robot was going to be the main parent, so that was what I called body. Then I knew that everything else was going to kind of hinge off of this. So if I wanted to move the robot around, I was going to grab the body and everything else was going to follow. So I then parented everything else to that main piece of geometry. And this could be a geometry, or it could be a group in which other things are attached to it. It really doesn't matter. So you can see up here I've got the left and the right hoop, and these are simply childs of the main parent. Then we've got the left and the right shoulder, and they have the entire arm structure connected. So if we just go with the left shoulder, you can see as I open that, that is actually just a group. And inside of that group we have the left shoulder here. They've just called it the knob. It's just this kind of circular shape, and the flange which connects to his arm. Then we have the upper arm as well, and the upper arm is connected directly into the shoulder, as these two are as well. But the upper arm then has the lower arm connected as the parent, and then the wrist here, and then the left and right hand, or these sections. And these have all been set with the pivot point correct. So if we come in here and we make adjustments, you can see this would all animate correctly if we needed it to. Okay, so everything's working fine. I've also done the same for things like the neck. So the neck has the head connected, as we saw earlier, and then connected directly to the head as children are the sphere at the top and then the two eyes. So again, if we grab the head and we animate it, you can see that that all works fine. And then finally, we have the same thing happening as you saw with the legs. So we have the upper leg, which again has the pivot point set correctly, lower leg, pivot point set correctly, and then the foot here. Okay, so this is really pretty straightforward, just hierarchical setup. Anyone that's done any form of character animation understands putting things in order like this, making sure the pivots are all fine. But it's really the naming convention that we're looking at. These could all be still working as I've shown you, but the naming could be all over the place. So make sure that you name everything in a logical way, because that naming is then going to be used in Katana for applying materials and doing all the randomization that we want to do to add the organicness to the scenes. So let's just go back to our presentation. Okay, so we've looked at what the Alembic file formats can support, but what software supports what version. So at the moment, you can see from here that Katana 1.1 v6, which is the latest version as of recording, supports the Alembic version 1.0.5, as does Maya 2013 extension, or 0.5. Modo, Houdini, Soft, and 3ds Max. I haven't been able to find out whether they support the 0.5 release. I'm guessing Houdini probably does. Modo, I couldn't find out, and I'm not sure whether Softimage and 3ds Max are at extension release or whether they're just at the default 2013. And the new version of Nuke 7, and we're currently at version 3 as of recording, again supports 1.0.5. So no one out there supports 1.1 at the moment. So we've got no materials and we've got no lights available. But hopefully as soon as some of these update, and I believe the first one to update is going to be Houdini 13, that will then support 1.1, which will give us additional functionality. But then we'll obviously need Katana to be able to be updated for reading the Alembic format as well. So getting Alembic out of Maya, how does that work? Well, let's quickly jump back to Maya and have a look. So here is our robot. We literally can do one or two things. First off, you need to make sure that under Window, Settings and Preferences and Plugin Manager, you have your Alembic format loaded, and you should find it here in Maya 2013.5, and it's ABC, Alembic Export and Import, and they both need to be checked on. Okay, if you're not seeing these in your main plugin section, then the chances are you don't have the right version of Maya or the newest version. Okay, so that's all you need to make sure they are loaded. So we then get the pipeline cache menu appearing here, and in here you're going to have the Alembic cache. You may have something else underneath it, but I tend to turn that off. So you have normally just your Alembic cache here.